Hi everyone and welcome to the session. Thank you for joining. So we'll be starting with the session shortly. Okay, we'll be starting in a couple of minutes. We'll wait for some other people to join in and then we'll start. Hi everyone and welcome to this session. Hi everyone and welcome to this session. So today we are going to So today our session is based on the dataset certification preparation, and we are going to look at the overview of the certification as well as some sample questions, and we are going to revise some important data stage concepts that will help us in understanding the concepts for the dataset certification exam. So to start with, the exam in itself is the C2090424 in Firstware Datasage version 11.3, and you can find the information related to the exam on this particular link. The exam will be a multiple choice question and it will have 64 questions, and you will be given a time period of 90 minutes to be able to answer all those questions, and you will have to successfully answer and correctly answer 41 questions to be able to clear the certification exam. Okay, just a second. Okay, so there are 9 modules in the exam and they cover the various aspects of data stage. To start with, we have the configuration, which will probably cover your data stage configuration file and how you can define nodes and node pools within the configuration files. That would comprise of 6% of your questions in the exam. Then the other module would be metadata. So that would basically cover the framework schema and the runtime column propagation and so on. The next module is persistent storage, which would basically be dealing with all stages in data stage, which are used for storing the data, like the data set state, the file set stage, and the sequential file stage. So that has a bigger proportion in the exam, that is almost 15% of the questions in the exam. And then we have the parallel architecture, that is basically questions around your partitioning and parallelism techniques. The next set of questions would be based on the databases, how you can connect to databases and what are the various properties which are relevant to the databases, which can be configured using the data stage designer or the administrator. And then the next big topic is the data transformation. So that is 12%, that covers 12%, and that would mostly be covering your the transformer function. Excuse me, the transformer functions, again using the RCP for the transformer and so on. Then the next component is the job components, which would basically be covering your the join stage, the lookup stage, the aggregator stage, the change capture stage, and so on. And the next is job design. So job design is basically creating a good design using the data stage, data rules, your shared containers, balanced optimization, and all that stuff. The next module is monitor and troubleshoot, which is basically understanding the job score, the OSH, and things like that, how you can monitor the data stage jobs and improve the performance. And then the next module is job management and deployment, which basically deals with how you can deploy your data stage jobs, how you can import them, export them, use the various utilities provided by data stage. And then the last module consists of job control and runtime management, which is basically your sequences and how you can use the ds job command to run the jobs from the Unix screen, the Unix shell scripts, and so on. So these are the various modules, and you have the percentages assigned to each module based on which you'll be getting the questions in your certification exam. As we said again, it will be a 60-question examination paper, and you'll have to correctly answer at least 41 questions to clear the exam. Now, all this information, as I mentioned earlier, is given on the site, on the IBM site for the certification. So you can find all this information there, what component, what module comprises of how much percentage. But basically, you have to be clear with all the modules to be able to clear the exam. So you should have an understanding of all the modules, and that is what we are going to do in the session today. We are going to understand some key concepts which can help us to answer the questions, the kind of questions which are asked in the DataStage certification exam. So the very first thing that we need to understand, and probably if we have been working as data stage developers, then we might not have come across many scenarios in which we would have worked on, or we would have been able to get an understanding of these basic concepts which are related to the configuration of the data stage server as such, and the data stage configuration files, and those concepts. So the very first thing that we need to understand is that there are two kinds of systems on which data stage can be deployed. So those two types of systems are either the SMP systems, which are the symmetric multiprocessing systems, or the cluster or MPP systems, which are the massively parallel processing systems. So what is the difference between the symmetric multiprocessing and the cluster? So what we need to understand here is that the symmetric multiprocessing is a shared environment. So your hardware resources are shared across your processors. The memory is shared as well as the operating system is shared. So in a symmetric multiprocessing system, it uses less hardware in terms of sharing the hardware among the various processors, whereas in a cluster or MPP, which is massively parallel processing environment, you have the processors have exclusive access to the hardware resources. They can communicate via high speed network which is a separate network. They have their own operating systems. So it is also known as shared nothing because none of these features is shared in a cluster or MPP system. Then the next important concept is around the configuration file, around which you'll mostly get a lot of questions. So most of your questions would be based on the configuration files, and probably as developers you have not got the opportunity to create a configuration file. But we should always have an understanding of the configuration file, and this is how our sample configuration file looks like. So configuration file is basically a file that defines that your parallel jobs would be using how many nodes to execute. So it will basically define the degree of parallelism in your job. So this is how a sample configuration file looks like. You define your nodes. So it can be a two node system. For parallelism, if it is only a single node, then it is only sequential. So you cannot have parallelism in that case. More than one node becomes a parallel architecture. So you define your nodes. It could be a two node system, it could be a 24 node system, it could be a 64 node system, and so on. So the larger amount of data, basically in real life projects, the more would be the number of nodes to increase the degree of parallelism and the execution of the data stage jobs. So you define your node, then you define your fast name, which is just a name, with a virtual name for your node. Then the next thing that we can see is the pools. So you have a default node pool, which is defined by double quotation marks. So that is a default node pool. So the node is part of the default node pool. By default, all the jobs would be running using the default node pool. So whatever nodes you define to be a part of the default node pool, and you run your parallel job, that job would be making the use of all the nodes which are defined in the default node pool. If you want to run it to a specific node pool, then you have to constrain the stages in your data stage job to run on a specific node pool. And that is where the node pool names come in handy. So for example, this node in this example sample configuration file, node 1, is part of the default pool, which is indicated by double quotes. It is also part of the node 1 pool, which is a named node pool. So now if I want to run my job only on the nodes which are defined in the node 1, so it is basically the stages in the job and not the data stage job in the whole as such. So you can constrain your data stage to run on a particular node pool. Then you can define exclusive resource disks which would be used by this node. So you have defined your user resource, two resource disks have been defined, and then you have defined your scratch disk which can be used for this node. You have a scratch disk which is belonging to the default pool of the scratch disk, and then you have a scratch disk which is a reserved name pool which is called the sort. So probably you will be using it only for the sort operations. So this is useful in cases when you are sorting a huge amount of data, and when you're sorting a huge amount of data, you do not want it to impact the other nodes in your job, because you might be having database nodes and so on. So you do not want it to impact the other nodes in the job, or you do not want it to impact the other parallel jobs which are running at the same time as your current job. So you want to separate out the sorting process to a separate set of scratch disk nodes. So in that case, you can define a reserved name pool which is called the sort. So your questions would be around basically, if you want to constrain your job to run only on node 1, then which pool should you be using constraining your stage 2? So questions would be, these kind of questions would be there in the certification exam. We'll see the questions later on. Now this is simply the description of the node options which we saw. A node name is a user-defined name of a processing node. So you can have any name, you can define any name. It depends on you how you want to define a node name. You can call it ABC, you can call it node 1, node 2, node 3, whatever you want. Fast name is simply a name that the computer system would recognize. So it is basically a virtual name. Then you have pools. You have two types of pools. You have node pools and you have resource pools. Node pools are the name of pools to which a node is assigned, so it's only a logical grouping of nodes. And the resource pools are the ones to which the resources are assigned. So which are the resources? Resources are basically your resource disk, your scratch disk. These are your resources. Nodes are basically the number of nodes you're creating. For example, in this sample configuration file, the node is node 1. And default pool is simply double quotation marks empty string. So it is the default which all your stages in your data stage job would be using if you do not define a separate node pool for those stages. The resources are simply two kind of resources. You have your disk resource and the scratch disk is a resource. Disk is a hard disk resource. For any storage of data you need a disk. Scratch disk is basically temporary storage of data. So if you're performing a sorting operation, then you need to store all that data in the memory and on the scratch disk somewhere to perform your sort operation, which is a temporary storage of data. You need to write it down somewhere temporarily. So that is your scratch disk. Okay, so data remains temporarily on the scratch disk, but if the sort operation involves a lot of data, then you need enough space in your scratch disk to be able to contain all that data. So that is where the scratch disk becomes important. So these are your resource pools. Resource pools, as we saw, would allocate the disk storage. Default pool would be an empty string, and you can also constrain the operators to run on a named resource pool. So if you have a resource pool and you define it as sort, you can define your sort stage to use that resource pool when you are executing your data stage job. So you have the sorting resource pools where the resources can be specified for sorting. Scratch disk will be available for sorting. Now the sort operator can use the sort disk pool. It can also use the default disk pool. Okay, so if you define a specific disk pool, which is the sort disk pool, then by default the sort operator would first uh, go for the resources in the scratch disk pool, and if that becomes full, if it needs more space, then it would look for the default disk pool. So this is another configuration file example. There are multiple nodes, as you can see. Now this is a 4-node configuration. So you have a degree of parallelism here is 4. You can have four instances running concurrently of any of the data stage. And you can see the first node, the namings are user dependent, so they have named it as n1, n2, n3, and n4. First name is for the computer system, so it is called s1, s2, s3, and s4. Now you can see the first node is allocated to the default pool, which we can see by the empty string. It is also allocated to a pool called n1, which is almost the same name as a node, so that is kind of a convention. Then it is also allocated to s1, so they have given by default the name of the node as well as the first name of the node, and it is also assigned to a pool called sort. So your sort operator can use this pool if you define to use it. Then it has the resource disk allocated to it. It also has a scratch disk allocated to it. Now node 2, you can see uh, you have your pool as n2, default pool s2, and app1. Node n3 is also assigned to the pool default pool n3, s3, and again app1. And node n4 is also assigned to n4, s4, and app1. So the kind of question that you'll be getting here based on the configuration file is, if you want to run your job, if you have it now, you can see that this is a 4-node configuration file. So if this is the configuration file you are using in your parallel job, but you want to run a specific job sequentially, then to which node pool you should assign it. Okay, so you can assign it to any of the nodes separately. You can assign it if you want to run it sequentially. You can assign it to the sort node pool because that contains only one node. Now this is a 4-degree parallelism. This is a 4-node configuration file, but let's say we only want to use the 3 nodes in our configuration file for the execution of the Datastage parallel job, and the only for the sort stage we want to use a node n1. For all the remaining stages in the job, we only want to use the nodes n2, n3, and n4. Then how would you achieve this in your Datastage job? So this can be achieved simply by constraining all the other stages in the data stage job to use the node pool app1. So app1, as we can see, contains 3 nodes n2, n3, and n4. So that would provide a 3-degree parallelism to the other stages in the job. And the sort stage, we can constrain it to the sort pool. So it will only be using the node n1. Right, so this is how you can configure the different stages to use different nodes, different set of nodes in your data stage job. And this is where your questions would be based on in your data stage certification exam. Now this is one example of the question that you will get. The question simply is that a data stage job needs to be designed to perform a join on 2 very large data sets. The sorting of the data is impacting the performance of the other batch jobs running along with this job. Now, this has led to a need to perform the sort operation on a subset of specific nodes. Which 2 steps will help achieve this? Okay. So the question here is that a join is being performed, and as you know, a join stage requires your data to be sorted. So this data that needs to be sorted is very large in volume, which is affecting the other batch jobs which are running in your dataset server. So how do you handle this? You want the sort stage to be constrained to a specific subset of nodes. So how you can handle this? So this can simply be done. You have your options, you have the various options. You have to go through these options. This is the format in which you'll get the questions. You'll have a question, and then you'll have the different options. You'll be asked to select a certain number of options. So they have asked you to choose 2 options. So the 2 options, as we have already seen, the 2 steps that need to be done is to create a subset, create a node pool only for the sort operation, and then constrain the sort stage to use that node pool. So if you see, the options would be specify the appropriate node constraint within the sort stage and define a non-default node pool with a subset of nodes in the parallel configuration file. So that would be your option. This is how you have to go about it. Okay. So this is one of the questions. This is the kind of question that would be asked in your certification exam. Now the next big topic is the parallel architecture, and that is the biggest strength of Datasage. It's parallel architecture. So we have to be thorough with the concepts of parallel architecture. Now parallel architecture is basically 2 kinds of parallelism you can expect in a Datasage job, which is the pipeline and the partitioning, as you can see. Now, this is a job that has no parallelism. So you have a source stage, which is like a database stage, an Oracle stage. You're reading data from it, you're transforming data in the transformer, and then you're writing it to a DB2 stage. So if you can see, if the job has no parallelism, then the first stage executes completely, it finishes execution, then the next stage starts execution. Once the next stage finishes execution, then the third stage starts execution. So this is a sequential flow. So the time taken would be the total of the time taken for the first stage, then the time taken for the second stage, and the time taken for the third stage. This is a job running with no parallelism. Now let's say we had pipeline parallelism in this job, and we can see that the time taken has been greatly reduced. But what is pipeline parallelism? Pipeline parallelism is simply that the next stage starts execution as soon as the first stage has finished processing some of the records. So it does not wait for the previous stage to finish its execution completely. As soon as it has partly finished execution and produced some output records, the second stage would start its execution. So some of the execution here is taking place at the same time, so the timing would be saved. This is your pipeline parallelism. So this is with the analogy of a pipeline or an elevator belt, where your data keeps on flowing continuously. You are not waiting for the previous stage to finish and output its data completely for the next stage to begin. Your data from the first stage is flowing. As soon as some output is produced from the first stage, the next stage would start processing the records. So this is your pipeline parallelism. This is one way how time is saved for the execution of a data stage job. And then the main kind of parallelism is your partition. Partition is basically dividing your input data stream into multiple subsets of data. So it is something like threading in a Java or C language. So it is basically dividing your input stream of data. For example, we have 10 records in the input stream, and we need to use a 5 node configuration. So we want 5-degree parallelism in the job. So what we can do here is we can make 5 partitions. So we'll each partition, or which is a node in the configuration file, would be reading 2 records each. So we have a total of 10 records. So 2 records each would be read, and the stages on your data stage job will have the 5 instances. So now the transformer has 5 instances. Each instance of the transformer is processing those 2 records at the same time. Those 5 instances are executing at the same time. So now your time is greatly reduced again. Your time is reduced by 5 because you have 5 partitions. Now this is the main kind that you need to understand, because as a data stage developer, you need to define the kind of partitioning which would be the best or optimum for each of the data stage that you're using in your job. So that depends on the developer, and that is where an understanding is needed of the kind of partitions which would yield the best results or the optimum results. So again, from the perspective of the certification, this is a very important topic. We need to have a thorough understanding of the different kinds of partitioning techniques which are available, and for which stage, which partitioning technique is the best or the most optimum technique to use in a particular scenario. So we need to have an understanding of that as well. So here you have the first kind of partitioning, which is the round robin partitioning. Round robin partitioning is nothing but dividing the input data set. So if you have 10 records in the input data set and you have a 4-node configuration, the first record goes to the first node, the second record goes to the second node, the third record goes to the third node, the fourth record goes to the fourth node, the fifth record again goes to the first node, the sixth to the second node, and so on. So this is a cycle that repeats, with your data going sequentially to each node. Each data record from the input going sequentially to each node in a particular order. So this is your round robin partitioning. Now this is best used or best needed in cases where you want an equal distribution of data, because using this technique you are seeing that each record is going to each node subsequently. So each node is going to get almost an equal number of data records. So that would result in equal partitioning of data. Now, if you have 4 partitions in your job and each partition has 2 records to process, they would be taking a same amount of time. Each instance of the stage would be taking the same amount of time, almost the same amount of time to process those records, and that would result in a better performance of your job. But if you split your data unevenly, if you have 4 partitions in a job, so 4 instances of, let's say, the transformer stage, and one instance has 8 records, and the other, or one instance has 5 records, and the other instances have 2 records, 1 record, and so on. Then when you have unequal records across partitions, the partition that has 5 records obviously is going to take a large amount of time to process. So in that case, your data your processing time would be more as compared to if you had equal number of records across each partitions. That being said, there is always a need to have those kind of partitions as well, which we'll see later on. But if you do not need your data to be sorted or grouped on any particular key column, if there is no particular requirement of any particular specific sorting or ordering of the data, then round robin partitioning is the best partitioning technique because it allows for equal distribution of data across the nodes, and that's why the data stage job performance is always optimum. The next kind of partitioning is random partitioning, where your records will go randomly to each node. So when it goes randomly, there's an overhead in calculating which node it should go to, and then you might not end up with equal number of records across each partition. This is a random partition technique and actually randomly used on the job, so not that important. The important one is obviously round robin, and then you have the same partitioning which basically maintains your partitioning state of the previous stage. So whatever partitioning you had in the previous stage, it would just carry it forward. So if you're using a joint stage probably and sorting on the customer id field, let's say, and then you have a remove duplicate stage which again you need to sort on the customer id field, then you do not need to repartition your data for the remove duplicate stage. You can retain the same partition, and that is called the same partitioning. This is also very important because this saves a lot of time. This is one of the key techniques of optimizing the performance of your data stage job. So you need to have a good understanding that you do not need to repartition your data for the next stage, and you need to explicitly go to the stage and configure same partitioning for that stage to retain the partitioning from the previous stage. Entire partitioning is almost only used for the lookup stage. It is very important for the lookup stage because it allows the entire copy of your input data to be available across all nodes, and it makes the lookup operation very fast. So lookup operation, as we already know, is basically stores the reference data in memory. So if your reference data is available across all the nodes, then your matching from the input data to your reference data is very fast, that processing is very fast, and that makes lookup very fast. So if you're using the lookup stage, then you have to go for the entire partitioning. But keep in mind that your reference data is small enough to fit well into the memory, because if it is not, then this would be a problem because this would be copying all the data from your input to each node, which would consume a lot of memory. So you have to keep in mind the reference data side. But if it is small, if it is like a lookup table, you're just doing a lookup with validating data with a set of records, then this you have to go for entire partitioning. And then the most important partitioning is your hash partitioning. Hash partitioning, as we mentioned earlier, some partitioning techniques will not result in equal number of data across partitions, but those are also needed. Those are needed in all the stages, all the transformations in the data stage job, which include calculations on the key columns. So if you are using a join stage, you need to have hash partitioning. Otherwise, you'll not get the correct results. So you need to have hash partitioning for join stage. You can use it for the lookup stage as well. You need to have it on the aggregator stage. So wherever you are grouping, so you're grouping by the customer id, then you need to sort it, you need to hash partition it by the customer id. Then you need to have it for the remove duplicate stage. You need to have it for all the stages which are based on a on a key column. If you are sorting the data, you need to hash partition it. If you are performing any such transformation derivation in the transformer, then also you need to hash partition it. So for any key based calculation, you need to uh, use the hash partitioning, which is one of the most popularly used partitioning techniques in data stage, and it is always used for the join stage, which is the most important example of a hash partitioning. It is used for the aggregator stages, sort stages, change capture stages, and so on. All right. Now, this is the kind of question that you would be getting in your certification exam. So, you will be given some displays or exhibits. So, in this exhibit, as you can see, we are reading from a sequential file, then there's a transformer, then there's an aggregator, and then we are writing the data to our data set. So, there are 2 points which are shown in this job, A and B, and the description on the question is that the job reads the columns department ID and employee name from the sequential file. So the sequential file has 2 columns, department ID and employee name, trims the employee name field in the transformer. All right, so the trim operation is performed in the transformer, and then performs a count of employees in each department in the aggregator stage. So now it's performing the count of employees in each department. Okay, so the question here is, which partitioning technique should be used at A and B in the exhibit? So A is basically while transferring the data from the sequential file to the transformer, and B is transformer to the aggregator. Which partitioning technique should be used over here? So think about it based on what we have discussed about partitioning. So sequential file to transformer, what is being done in the transformer depends, the kind of partitioning that we need depends on what operation is being performed in the transformer. So the transformer is only trimming the data, trimming the employee name field. So it is not a key based operation. We are not sorting the data, we're not grouping the data, we're not counting the data, there is no key based operation being performed. So as we discussed earlier, the best technique here would be to have equal size partitions, equal size data across all partitions, and the best partitioning technique to do that would be round robin. So what you can specify over here is round robin. Then the next part B is between the transformer and the aggregator. And we have been informed that the aggregator is used to calculate the number of employees in each department. So if it is calculating the number of employees in each department, it must be doing a grouping by on the department ID. If it is doing a group by on the department ID, then we need to use the hash method of partitioning for the group by. So we need to use the hash partitioning over here. So the correct answer here out of the all the options that would be given to you would be round robin and hash. Okay, so this is how you have to come, you have to decide, and these are the kind of questions you will be asked in your certification exam. Now there is another question based on the same exhibit, and that says that the scenario is the same. um, it asks you which column should be used as a key for partitioning between the transformer and the aggregator. So the aggregator is doing a count on the number of employees in the department ID. So which column should be used? Since we are counting the number of employees in a department, so we have to group by the department. So the grouping by should be on the department ID. The partitioning would be on the same column on which we are doing a group by. So the group by is on the department ID. So the partitioning, as we earlier discussed, hash partitioning would be on the department ID column. Okay. Okay, so next kind of question, you can get simple questions. Which partitioning method would yield the most even distribution of data without duplication? So we have already discussed this multiple times now. This is going to be the round robin method. Okay, so moving on the next set of concepts, which are around the persistent storage. Now, what is persistent storage? Storage which is which takes place somewhere in your hard disk. So which is physical storage is your persistent storage. Now the most commonly used stages for this kind of activity in a data stage job are the data sets and the sequential files. So the concept that we need to be clear with now is when to use a data set and when to use a sequential file, and what are the properties of these two different stages in data stage. So data set, if you're already working with data stage, you would know that it is in the native data stage format. So it has a descriptive file and a data file. Okay, so it is not a Unix file, that you can use simple Unix commands on like rm -f or cat. Okay, it is in the native data stage format. It is partitioned, so the data is partitioned in a data set, and it the format of a data set is a descriptive file and a data file. Okay, they are stored on disk. That's right. And the kind of commands that you need to deal with the data set are the org admin commands. So this, you need the org admin commands. You cannot use the simple Unix commands like rm-f or anything. You need to use the org admin commands here. Okay. Now, to deal with data sets, there are two ways you can deal with data sets since you are unable to use the Unix commands with data set. There's also something called the dataset management utility. So, if you're not comfortable using the org admin commands, you can use a GUI based interface. So, it's a GUI based interface, the dataset management utility, and you can use that to deal with the data sets, wherein you can delete the data set, you can duplicate the data set, and so on. All right. Okay. Okay, so the kind of question you will get is which attribute is found in a dataset descriptor file. So you need to have an understanding of the structure of a data set. As we said, a data set consists of a descriptor file and the data file. So it's not a data file, it can be data file. So depending on the amount of data that you can have multiple data files associated with a data set. Now a data set has an extension of .ds, as we already know. It is used for intermediate storage of data because it is in native data stage format, so we cannot use it externally. But since it is in native data stage format, it is very fast to be processed by data stage because the data is also partitioned in a data set. So it is used for intermediate storage of data. But now we need to understand some more concepts about data set, like what is the structure of a data set. So a data set consists of data files and a descriptive file. The next question, the kind of question that you would be asked in your certification would be around the structure of the descriptive file, what it contains. So this is the kind of question you'll get: which attribute is found in a dataset descriptive file? So the correct answer in this case is a copy of the configuration file used when dataset was created. But to know all the things that are present in a data set, you have to understand that the descriptive file for a data set contains the following information. It contains the data set header information, it contains the creation time and date of the data set, it contains the schema or the metadata of the data set, and a copy of the configuration file used when the data set was created. Okay, so all this information you need to memorize what all it contains, the dataset descriptor file. The second important thing about dataset, how can you handle the datasets? Either by using the org admin commands or using the dataset management utility. So these are the two important concepts you need to understand about datasets. And the third point around which you might get questions are around the restartability of the data stage jobs, designing the data stage jobs in a fashion in which they are restartable. So the best technique to do that is design your data stage job in modules. For example, if it is an extraction transformation load job, then instead of designing a single ETL job wherein you're reading data from your source, then using a transformer to do the transformation, and then writing data to a database stage, you can split the same job into three parts. You can have an extract job where you read the data from your source, store that data into a data set. Then you can have a transformation job wherein you read the data from the data set you created in your extract job, perform your transformation using transformers and other stages, and then write the output to another data set, and then create a third job which is will be your load job, and use the data set created in the transform job to load the data into your database. So what are the advantages of this process? The advantages are that in case, let's say, your transformation job failed, something your transformation failed, then there's no need to read the data again from your source stage. So this helps in restartability of the data stage jobs. So this data sets are a good way to store data. Now that being said, um, There's also a concept of staging tables and data warehouse. So if you need to analyze data, then which you have read from the source in some ways to find out exactly where the error was, and you do not want to hit the source system, which we do not want to do in real-time projects, then you can, in the extract stage, you can store the data. Instead of storing it in a data set, you can store it in a staging table. All right. Now, there's another concept called file set. File sets are rarely used, but from the perspective of your dataset certification, you might get questions around those. So you have to understand that a file set is similar to a data set. It is also a persistent storage technique in data stage. They are also partitioned. They also have your header file and data files. But the difference in case of a data set and a file set is simply that the data in the file sets, your data files are text files. So they are readable by external applications. They are rarely used, but you might get questions like this, that I want to store data in a data stage job wherein I have got data which is partitioned, but it should also at the same time be readable by the external application. So, what can be done? So, in that case, your answer will be file set. In real time scenarios, though, we rarely use file sets nowadays. Okay. So, this is another example of the job that you will get, the questions that you'll get in your dataset certification exam. So an ETL job is to be created with the condition that if the transformation code fails, then it should be restartable from that point, meaning there should not be a need to connect to the source database again, which design technique would yield the fastest performance given no external application needs access to this data. So now we have been clearly specified that no external application needs access to this data. The job needs to be restartable, and we do not want to connect to the source database again. And we want the fastest performance. So what would you do? Would you use a sequential file, a file set, a data set, or a lookup file set? So obviously the answer here would be your data set. If they would have said that an external application needs access to this, then we might have gone for a file set. Okay. Now, the other next very important thing, and sequential files are your Unix files or flat files or text files that you can create, which are obviously accessible by all the external application. So sequential files, in terms of sequential files, there are a lot of properties related to sequential files. So you really need to go through all those different properties which are available in sequential files, how you can collect output records from sequential file, how you can collect reject records from sequential file, how you can remove header and trailers from sequential files. um, so there are a lot of properties associated with sequential files. So make sure that you uh, read and understand each and every property of the sequential file. But what we're going to discuss here is one of the important concept again, which is parallelism in sequential files. So you'll most probably get a question around this topic in your certification exam. So there are two ways to achieve parallelism in a sequential file. Now, sequential file, as the name suggests, should ideally be running in a sequential mode. That is why it's called a sequential file probably. But if you're running it on a single node and you're reading a single file, then there are ways to improve your performance. So that is through the two options, read from multiple nodes and number of readers per node. So if you have multiple nodes in your system, okay, so it's like a cluster system wherein you have multiple nodes, then you, if you set read from multiple nodes as yes, then a single sequential file that you are reading would be split across nodes, and all those node data across all those nodes would be read in parallel, and that would give a degree of parallelism to your sequential file, and that would obviously improve the performance. So if the file is too big, if there's lots of data and it's taking a lot of time to read the file, then you can go for this option if your system is a cluster system. Now, if it is a symmetric multiprocessing system, that means you do not have too many files, then Okay. uh, if you do not have multiple nodes, then also you can achieve a degree of parallelism in the sequential files. And how can you do this? You can do this by setting the number of readers per node property to more than one. Okay, so you can set a value, you can set it to one, you can set, if you set it to one, then it would be sequential. If you set it to two, then it would assign some virtual readers to every node, to a single node that you have in your configuration file. So you have a single node, it would assign some logical points to it, logical partitioning it would do, and then it would split the data across those two logical partitions, which are readers for a node, and it would read that data at the same time. So it would achieve a degree of parallelism for the sequential file. So if you have a single node configuration, then you have to set this option number of readers per node to greater than one. You can set it to two, three, four, five, whatever you want. You can set it that way. Okay, but you have to understand how much is the optimum number to be set. So you can, depending on your volume of data, you can run it a number of times and come to an optimum number. And it also depends on the processing power of your node. So you have to take all these things into account. So you have to run it a number of times and you can come to an optimum number. Now, the other thing you need to remember is that these two properties are exclusive, mutually exclusive. So you cannot set them both together. You cannot set read from multiple nodes as yes and then number of readers per node to more than one. That is not possible. If you set read from multiple nodes as yes, then the other property is automatically grayed out. Okay, so you can only set one at a time. Now, the kind of questions you will get around sequential file, and there would be a lot of questions. So as I said earlier, be sure that you are thorough with each and every option of the sequential file that it has. Okay, so which reject mode option in the sequential file stage will write records to a reject ring? So for some reason, if your sequential file, you have 10 records in your Unix file, but your sequential file is only reading 8 records and you do not know what is happening with the other records, then add a reject mode link. Okay, how can you create this reject mode? You will have to give the option as output. Okay, the reject mode should be output. So there's a property called reject mode in the sequential file configuration stage editor. You have to set it to output. All right. Now, the next kind of question you'll get is, a single sequential file exists on a single node. To read the sequential file in parallel, what should be done? So as we already saw, if there's a single node, then what property needs to be set? Number of readers per node should be set to greater than 1. Okay, set the number of readers per node optional property to a value greater than 1. So you'll almost always get a question around this, either reading from multiple nodes as yes or number of readers per node as greater than 1. So be thorough with these concepts as well. Okay, now some questions around the metadata. So some common concepts, like we have all seen runtime column propagation in a job. Why do we need it? If we do not want to explicitly define the columns, we are just propagating the same columns from the input till the output, then we can just use the runtime column propagation option. So that is the RCP option. So you'll get a couple of questions around this as well. So where can RCP be enabled? It can be enabled. It has to be enabled in your data stage administrator. As you can see in this window, you have to enable it in your data stage administrator first, and then you'll be able to enable it in your parallel job. Okay, so you have to understand this as well. And the question would be around this. Also, where it is used in terms of sequential file. Also, if you have come across the schema file in the sequential file, so when you read sequential file in detail, you will come across something called the schema file as well. So schema files are basically when you have a dynamic structure of the input data files. So you are provided schema files, which are nothing but again Unix files, kind of Unix files or Windows files. Okay, and they contain the structure of the data in terms of the column names and so on. So based on that schema, you can define your structure in your data stage job. because you do not know it beforehand, because it is a dynamic structure. So in that case, RCP can be used, because you anyways do not know what kind of structure would be coming. So RCP is very helpful in that case. Okay. Now the question is, runtime column propagation cannot be set in the datastage job. Which action can re-enable this? So as we have just seen that it needs to be first set in the datastage administrator, and only then you will have an option to set it in your datastage parallel job. So this is how you can do it. Okay. So the other part that we should be comfortable with is the aggregators, the joins, the sorts, and so on. So they come under the module called the job components. And the important part in the aggregator we have all used, and we know it is used for doing the calculations, for doing the counts, summations, and so on. Okay, now for aggregator, what you have to remember is, what is the output, default output of the aggregator? The default output of the aggregator is a double. Okay, now in aggregator, a thing that we need to understand for improving the performance of the job is which kind of aggregator method to be used, whether it should be hash or sort. Now, two kinds of aggregator methods are available: hash and sort. Hash is to be used when you have a limited number of key columns or a limited number of distinct groups. So if I have only 4 categories, I know that my input data contains only 4 categories. So which is like, okay, the number of continents in the world. So I know it is only a fixed number, a limited number of groups that I'll be having in my input data. Then I can go for the hash technique, because the key groups are limited. Okay, so it can hold all that in a hash file in the memory, hash table in the memory, and it can process all that information, and then it can output all the rows once the results have been created. So it is useful when the number of unique groups is small. The other method is the sort method. Now the sort method, what is important in the sort method is when your key columns are too huge. So you have, let's say, number of cities in the world. Now you know that there are so many cities in the world, and you are grouping it by that. Then you cannot hold all those groups, thousands of groups in your hash memory, in your data stage. So in that case, you need to go for the sort stage. Okay, in that sort method, and you need to sort your input data. So when you have unlimited number of groups, you have to go for sort method. So that would give you an optimum performance. So this difference you need to be clear with, whether to use the sort stage or the sort method or the hash method in an aggregator. So hash method, because it stores all the data in terms of hash table in the memory, the number of unique groups should be less for hash method. For sort method, when you have unlimited number of groups, so many key values. Okay, now a join stage. Join stage would use hash partitioning. The kind of joins which can be performed in a join stage, you can have left outer join, right outer join, full outer join, inner join, matching data from both the links. Left outer join, all the data from the left link, only matching data from the right link. Right outer join, all the data from the right link, only matching data from the left link. Full outer join, all the data from the left link and the right link, and values for attributes for non-matching records will be populated as nulls. Excuse me. Then lookup. Now lookup we have all used. We keep on using the normal lookup, but there is another option in the lookup called the sparse lookup. When to use the sparse lookup? So sparse lookup is the option that needs to be used when your incoming data is greater, much greater than your reference data. I'm sorry, the other way around. When your incoming data is much lesser than your reference data. Okay, so because my incoming data is less, much less, so I have, let's say 10 records in my incoming data, and my reference data has 100 records. Okay, so I can use sparse lookup because it will yield a very fast performance, because sparse lookup works in a way of executing individual SQL statements. So for every record in my input stream of data, a SQL statement would be fired, and it would search for a match in the reference data and it would provide an output. Then the next record would be picked up, a SQL statement would be fired, it would search for the data and then return the output. Now, since I have only 10 records and my reference record were 100 records, this is going to be a very fast operation as compared to a normal lookup, in which I would have hold all the 100 records in memory, then I would have read all the 10 records together in one partition and then done a match. So in this case, this is going to be much faster. A sparse lookup is going to be much faster. Okay, now some questions related to the job management and deployment. So what you need to understand here is the different dataset user roles. So if you have never got the opportunity to create a dataset new user and assign a role to it, then you need to have this understanding as well, that there are 4 different user roles in dataset. A developer role, who has full access to all areas of a dataset project. A production manager, who has full access to all areas of a dataset project and can also create and manipulate protected projects. So protected projects, a developer cannot deal with protected projects. Operator, who has permission only to run and manage dataset jobs, and super operator, who has permission to run and manage dataset jobs and to view them in designer as well, but he cannot edit them. So these are the different dataset user roles. So just memorize these roles, and this is how it actually appears when you create a new user. You have an option to assign a user role over here. This is in dataset administrator. Then the next important concept that you need to understand about dataset is the background execution of a dataset job, how it actually happens. Okay, so this is a job execution, the orchestra metaphor. It is called the orchestra metaphor. Now you can see that in the background you have different nodes. So note, there is a main node which is called the conductor node. Now, the conductor node handles all the other nodes, manages all the other nodes, which are called the processing nodes. So a conductor node, as you can see, it is responsible. The initial startup process that is happening with the parallel job is taken care by the conductor node. Excuse me. Okay, it creates your OSH. OSH is your orchestrated script language that is created. Okay, which is what your dataset job is converted into in the backend, and then that is the script which is executed when you execute your dataset job. So the conductor node is responsible for that. Now this conductor node then calls upon the different processing nodes, and these processing nodes within themselves have a section leader, and then within a section leader they have player processes. A section leader would have multiple player processes. So a conductor node is the main node that would have multiple processing nodes. Within a processing node, you would have a section leader which would be controlling multiple processes. Processes are the lowest levels. So they are the actual places where the operations are taking place. The actual transactions are taking place here. They're sending the error and information messages. They're establishing the connections and so on. The section leader is just controlling these different player processes. So it is forking out the player processes and managing the communication. And the conductor node is controlling all these player nodes and the processing nodes and the section leaders and so on. So this is how in the background your job execution takes place. Then you have to understand OSH terminology, because there would be some questions around this as well. So when you say a table definition in terms of OSH, it is schema, a property is a format, a SQL column type is a C++ data type, a link is a virtual data set, a row is a record, a column is a field, a stage is an operator. Now, when you create your ASA job, compile it, execute it, it is in the backend, as we said earlier, is converted into the OSH code. Now, this OSH is actually has many operators in which it would convert your data stage job. So you have to again know these operators. For example, if it is a sequential file stage, then when it is used as a source, it is the import operator. When it is used as a target, there is an operator called the export operator. A dataset stage is a copy operator, a sort stage is a tsort operator, an aggregator stage is a group operator, a row generator stage, column generator, surrogate key generator, all map to the generator operator. Oracle, you have these different operators, and lookup file set, you have these different operators. So you need to memorize these operators as well, because there will be questions around these as well. The questions would be like, when sorting the data in a data stage job on the customer ID field, which OSH operator is inserted? So what is the operation being performed? Sorting operator operation. So the operator would be your tsort operator. Okay. Okay, then data transformation. Data transformation is basically your transformer stage. Okay. Now, transformer stage, an important concept regarding the transformer stage, and a question that would mostly be there in your um data stage certification exam would be relating to the use of a transformer or a filter. So, you will be given a case scenario and you will be asked whether it would be a good idea to use the transformer stage in that job or a filter stage in that job. Okay, so for example, this question that we have here, the question here is, the same data stage job runs as a separate instance for each state in the USA. The state name is passed as a parameter. You're trying to decide whether to use a transformer or a filter stage to accomplish this. Which statement is true? Okay, so the scenario that we are given is basically that a data stage job is there, and the same job is being used to run or process the data for the different states in the United States of America. So that state name is a parameter here. Okay, so now, do you want to use a filter stage here or a transformer stage here? Which would be give a better performance to filter this data out by the state name, where the state name is going to be a parameter? So the answer here, and the concept, the basic concept that you need to know here, because there would be a different kind of question but based on the same concept, and therefore you need to understand the concept first. The concept here is basically that a transformer always yields better performance when your where clause has a dynamic parameter. Okay, so filter, in a filter stage where clause is interpreted at runtime, that decreases the performance of the data stage job. So if you're passing the parameter, your where clause filter, as a parametric value or as a dynamic value, then a transformer will always give a better performance than a filter stage. Now, transformer is going to have a good amount of questions. So you know that there are various options in a transformer. You need to understand the state, the order of execution in a transformer, how the stage variables are executed, then the constraints executed, then the output records are derived, and all those derivations are processed. You also have options to like abort the job in a transformer. You also have option called the otherwise link. So there would be questions around that. For example, this question is around the otherwise link. This question is basically, the transformer stage in a data stage job has two output links. The first link has a constraint to output records of employees who are working in more than one project. The second link outputs those employees who have been promoted in the last 2 years. So there are two output links with two different constraints. An otherwise link has been created to collect the list of employees who do not fall in any of the above categories. The otherwise link is giving incorrect records. What might be the cause? So you have to be careful while defining your otherwise link in the transformer, in terms of that it should always be the last link in your transformer. Okay, if you have two links and you put the otherwise link in the middle of the other two links, then that is not going to work. Okay, so you have to have the otherwise link as the last link in the link ordering in your transformer. Then only it would work. So that is the question, that is the answer here as well. The otherwise link is the first link in the link ordering. That is why we are getting incorrect results. If it would have been the last link in the link ordering, we would have got the correct results. Okay. Now, another important question always, how to execute Datasage jobs from a Unix shell script, the ds job command. So you have to be familiar with the ds job command. There are various options which are used with the ds job command. So uh, read about the ds job command, because you can run the job, you can stop the job, you can make a log entry with the job. So what all can be done with the ds job command? ds job command, there would definitely be a question around the ds job command. Now, some questions around the Datasage administrator. As you can see, the generated OSH variable for parallel jobs in all projects. So visible, sorry. So if you want to see the OSH which is created for your Datasage job in the director, then or in your designer as well, then you have to select this option in the Datasage administrator. Another option that you can check in your Datasage administrator is to add checkpoints. So sequence is restartable on failure. Okay, so this is regarding the job sequences, wherein you can make them restartable by adding checkpoints. So if you add checkpoints, then if one of the job fails and you want to rerun the job sequence, then you can start it from the point of failure instead of rerunning the first job again. Another option that you can set in your Datasage administrator is the auto purge of job log. Okay, so you can do your the job logs if you do not do a purging of the job logs, and you can define how older than days or up to how many runs. If you do not put the job logs, they become too big and they consume a lot of space on your server, and that makes Datasage work really slow. So this is a very important option that needs to be set in the Datasage administrator. Why we are going through these options is basically because you will get questions around what are the options that you can set in a Datasage administrator. So you need to know what options can be set in the Datasage administrator. As we saw earlier, the runtime column propagation, then this auto purging of the jobs. We saw the checkpoints for the sequencers, if you want the OSH to be visible in the sequencer, and so on. So these are the various options you can set in the Datasage administrator. And what are all the other thing you can do in the Datasage administrator is obviously defining your environment variables. And there would be a lot of questions around the environment variables, so make sure that you know and understand about the important environment variables at least. So there are many which are set to default values, and they are important to be set to default values to make our data set jobs work well. As a developer, we might not have come across as many environment variables, but for the certification exam, we need a good understanding of these. APT config file, simple, where you define your configuration file. This is an environment variable where you define your configuration file to be used, otherwise it will use the default.apt configuration file. APT disable combination, there would be mostly a question around this, because this is how you can tune your job. So these are advanced performance tuning of the data stage jobs, which are which are the concepts that a data stage certification exam basically tests. Okay, so APT disable combination. So we saw that the OSH converts your stages into different operators. So sort operators, copy operators, and so on. So there, it basically combines these operators together while creating the OSH for different stages. So for some reason, if we think that, and that again, this needs advanced performance tuning of the data stage job and a very good understanding of the data stage job. If we do not want this combination to happen, then we can set this option through the environment variable APT disable combination. So the optimizations are done, or the operator combining is done for job efficiency and improving runtime. So if you set this combination, you have to bear in mind that no combination would be done, no combining would be done of the operators in the OSH, which would greatly impact your job performance. So this needs to be set only when it is impacting your data in some way. So again, advanced job uh, tuning, and you need to really understand your data and your system resources. Okay, APT monitor size, simple. How many records you want to see in your job monitor? Again, very important. Okay, a job monitor allows you to see what is the processing status, at which stage, how many records were processed, how much time it consumed, and if it failed, then at which stage. So, what is your monitor size you want to see? What is the monitor time you want to see? How, when you want it to be refreshed? If you do not want any job monitoring, then you can turn it off using the APT no job mon. APT no partition insertion. If you want that, then sometimes it has said job automatically would insert partition. If you do not want that, again based on an understanding of your data and your resources, then you can use the APT no part insertion. APT dump score, again very important. It creates a job score that again helps you to analyze the performance of the job. So you can set this particular thing, environment variable, and so on and so on. There are some other environment variables also which would be helpful for you in understanding the various things that you can do with a data sage job in terms of advanced performance tuning of a data sage job. So these are some of the topics that are important and some of the concepts which are important in terms of data sage certification exam, and you should really read up on these topics. We have given an overview of the kind of questions that you can expect for these topics, so you should really understand the concepts well. The idea in a data set certification is to really check your concepts. You would be given a lot of scenario questions, you will be given a lot of exhibit questions. You really need to understand your configuration files, the environment variables that can be used, what kind of partitioning to be used, what are the which stages have the reject links, how you can collect the data from the reject links, how you can performance tune your job. So these are the topics around which your knowledge would be tested in a data stage job. As a data stage developer, sometimes we do not have that much familiarity with all these concepts, which are also revolve around some data stage administration topics. So that is why we actually need to read up on these topics. As I said, the format of the dataset examination is available on the IBM site as well. Now, for the resources that you need to prepare for your dataset certification. So, you have your IBM site where it explains each and every stage. It explains the concepts of partitioning and everything. So you can read up on that. You can go through the various tutorials. So we have a lot of tutorials on our own YouTube channel, which is Learn at Knowstar. So you can subscribe to our channel, and there are a lot of data sage tutorials. So you can specifically look for the tutorials around the change capture stage, the slowly changing dimensions, which we have not been able to discuss in this session. Then you should look at the tutorials around the partitioning, the configuration files, and sequential files, the data sets, the aggregators, the joins, and so on. So if you go through those, then you will get a lot of understanding of the basic concepts, and at the same time, um, these are the kind of questions that we have seen. These would be the kind of questions you would be expecting in your data set certification exam. So this is all we have for the session today, and I hope you found it useful. And if you have any more queries, you can send a mail to our email ID learn.knowstar@gmail.com. As I mentioned, you can subscribe to our YouTube channel that has a lot of data stage tutorials, and more tutorials will keep on coming. So you can subscribe to our channel and take advantage of all those data stage tutorials. If you need a more in-depth training for the data to prepare for the data set certification exam, then we also have a course for that. So you can send an email to learn.knowstar@gmail.com, and we would send you information, more information around that course as well. If you just want the data stage sample questions, certification sample questions, a list of sample questions and some scenarios that you might expect in your exam, then we can share that as well. So if you need any of those resources, you can send me an email to learn.knowstar@gmail.com. In the description section, I'll also add links to all our YouTube videos, which would be especially useful for preparation for the dataset certification exam. And if you have any questions now, you can put them in the chat window as well. And other than that, thanks a lot for attending this session. And I really hope you found it useful. And we'll be having more such sessions in the future as well. So please keep on joining. Thanks a lot for attending this session. Any queries on more courses or any other queries, you can send a mail to learn.knowstar@gmail.com. Thanks a lot for attending this session. Once again, if you want to enroll for a specific course or you want a more detailed preparation course for the dataset certification exam, then you can send us an email. And since you have attended this session with us today, we'll offer you a discount as well. So you are welcome to send an email to learn.knowstar@gmail.com. Thanks once again for attending this session and have a great week ahead. Thanks again.